Hi there, welcome to my channel. In this episode, we will continue focusing on SPM formatted questions involving probability. Remember, you must practice. Practice makes perfect. Question 1. A and B are two events of an experiment such that probability A equals to 2 over 5 and probability B equals to 1 over 4. Find the value of probability A union B if A and B are mutually exclusive events. Okay, so let's see the formula. So the formula of finding probability A union B equals to probability A plus probability B minus probability A intersect B. Since the events given A and B are mutually exclusive events, therefore the probability A intersect B equals to 0. Now you can rewrite the equation as probability A plus probability B. You have the value of probability A and B, so substitute into the formula and get the answer. For the second question, you are asked to calculate the probability A union B if A and B are independent events. So if independent events, meaning we do have the intersection between set A and B. Okay, therefore we can find the probability of A intersect B. Okay, so probability A intersect B can also be written as probability A times probability B. Okay, substitute the values and simplify to get the answer. Question 2. Table shows the probability of Omar adding sugar and or creamer to his coffee. Okay, information given in the table. Probability sugar given as 1 over 3, probability creamer as 1 over 2 and probability sugar and creamer as 1 over 4. The first question, find the probability that Omar does not add sugar. Now you can find this answer by taking 1 minus the probability of adding sugar. That will give you the probability Omar does not add sugar. So 1 minus 1 over 3, you will get the probability of Omar does not add sugar, which is equals to 2 over 3. For the second question, find the probability that Omar add either sugar only or creamer only to his coffee. So when you have the word or, so you have to check whether this is mutually exclusive event or non-mutually exclusive event. So adding sugar and creamer can happen together. Okay, so let's find the answer. So first you define the events. Let A as adding sugar to coffee and B as adding creamer to coffee. Okay, so probability add either sugar only or creamer only. So remember you have the word or, so we are going to use this formula again. So probability A union B. Remember the word or also can be replaced using the symbol union. So probability A union B equals to probability A plus probability B minus probability A intersect B. So probability A will be probability adding sugar. So that will be 1 over 3 plus probability B, that is probability adding creamer to coffee, that is given 1 over 2, and minus probability adding sugar and creamer. Okay, so here probability adding sugar and creamer given as 1 over 4. So substitute all these values into the formula and simplify to get the answer. Question 3. Diagram shows two fair dice is thrown together. find the probability that the digit on the dice have a sum of 8. Now, before we continue to answer this question, you can first list out all the possible outcomes of the sample space. For example, the outcomes can be 1, 1, 1, 2, 1, 3, and so on. So altogether, you will get 36 outcomes. Therefore, the number of sample space equals to 36. Next, let A as event of having a sum of 8. Okay, so from the sample space, you can choose all the outcomes that will give you a sum of 8. So here, set A equals to 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. So the number of event A equals to 5. Now, since you have number of event A and number of sample space, now you can calculate the probability of event A. So what is event A? Event A having a sum of 8. Okay, so substitute the value. So it is 5 over 36. Now let's move on to the second question. So here you are asked to find the probability that the digit on the dice have at least one digit of 6. Now I've already mentioned this in the previous video. Okay, so when you come across the phrase at least, so it is equivalent to 1 minus the probability of the complementary events. So here, let's say B as having at least one digit of 6. Therefore, probability B equals to 1 minus probability not getting digit 6 for the first time, not getting digit 6 for the second time. Okay, so here not getting digit 6, that means you might get 1, 2, 3, 4, 5. Okay, the probability will be 5 over 6. So here probability not getting 6 equals to 5 over 6 times again not getting digit 6 will be 5 over 6. So multiply these values, simplify to get the probability that the digit on the dice have at least one digit of 6. So remember, when you come across the word at least, what you can do, you take 1 minus the probability of the complementary of the event. Question 4. Table shows the hometowns of a group of staff in a company. A staff is randomly selected from the company. Find the probability that the staff is from West Malaysia. Okay, to start with, let's find the number of sample space. You can find this value by adding all the staffs in the company. So total staff here we have 134. Let A as event of staff's hometown is West Malaysia. So in order to calculate the number of event A, you have to total up the staffs from Kuala Lumpur and Malacca. So that will be 116. So once you have these two values, now you can calculate the probability value using the basic formula of probability. Substitute the value and find the answer. Next, find the probability that the staff is from finance department or the hometown is Sabah. Now you have the word or here. Therefore, you need to check if these two events can happen together. What do you think? Now, if you say yes, these two events can happen together, then you are correct. Altogether, we have 4 of them working in finance department and the hometown is Sabah. Okay, so to continue, let's define the events first. So let B as event staff from finance department. So finance department altogether we have 29 of them. Let C as staff's hometown is Sabah. So from Sabah we have 18 of them. So using the formula probability B union C, I'm using union because of the word or. So probability B union C equals to probability B plus probability C minus probability B intersect C. So probability B, so it will be number of event B, that is 29 over 134, plus probability C, that will be 18 over 134, minus the intersection between B and C, that means staffs from finance department and Sabah, we have 4 of them. So 4 over 134, simplify to get the answer. Question 5. Naim and Bakri are invited to attend a wedding dinner. The probability that Naim will attend the dinner is 3 over 8, and the probability that Bakri will attend the dinner is 1 over 12. Assume that both Naim and Bakri do not influence each other to attend the dinner. Find the probability that both Naim and Bakri are attending the dinner. Okay, so first we define the events. So let N as event of Naim attending the dinner and B as event of Bakri attending the dinner. So the question is probability that both Naim and Bakri. So here Naim going and Bakri also going. So here we have only one possible outcome, and when you come across the word and then you multiply. So the formula can be written as probability Naim going times probability Bakri going for the dinner. Okay, so probability Naim attending the dinner given as 3 over 8, and the probability of Bakri going for the dinner is 1 over 12. So simplify this to get the answer. Okay, for the second question, find the probability that only Naim or Bakri is attending the dinner. Now here, if only Naim going, then Bakri not going for the dinner. Or if Bakri attending the dinner, then Naim will not be going or attending the dinner. So here we have two possible outcomes. The first one, Naim going, Bakri not going, or the second possible outcome, Naim not going, Bakri going. Okay, so before we continue with the calculation, we find the probability of the complementary events. Okay, so here given probability Naim attending the dinner as 3 over 8. Therefore, Naim not attending the dinner will be 1 minus 3 over 8, which is equals to 5 over 8. Next, Bakri attending the dinner given as 1 over 12. Therefore, Bakri not attending the dinner will be 1 minus 1 over 12. Which is equals to 11 over 12. So once we have this information, now we can continue with the calculation. So for the first possible outcome, Naim going and Bakri not going, that will be 3 over 8 probability Naim going times Bakri not going 11 over 12. Continue with the second event, or so you need to change it as plus. Now Naim not going but Bakri going. Okay, Naim not going and Bakri will be attending the dinner. So Naim not going will be 5 over 8 times Bakri attending the dinner is 1 over 12. Okay, simplify this to get the answer. Question 6. The probability that Raza qualifies for a scholarship is 3 over 5, while the probability that Azman qualifies is 1 over 4. Find the probability that both of them qualify for the scholarship. Okay, let's define the event. So R as event that Raza qualifies for a scholarship. The probability value is given as 3 over 5. Okay, the second event A, as event that Azman qualifies for a scholarship. So probability A equals to 1/4. For the first question, you are asked to find the probability that both of them qualify for the scholarship. So that will be probability Raza qualifies and Azman qualifies. And we have only one option here, or one outcome here. Okay, so it is also can be written as probability R times probability A. That means probability Raza qualifies, and you change the n as multiply probability Azman qualifies, probability A. Okay, now substitute the value and simplify to get the answer. Okay, for the second question, you are asked to find the probability that only one of them qualifies for the scholarship. So that will be Raza qualifies and Azman doesn't qualify for the scholarship. Or it can be Raza not qualified and Azman qualifies for the scholarship. So we have two possible outcomes. The first one, Raza qualifies, Azman not qualified, or Raza not qualified and Azman qualifies for the scholarship. Okay, since we have the probability Raza qualifies as 3/5, so the probability of the complementary event will be 1 minus 3/5, which is equals to 2/5. And if probability Azman qualifies is 1/4, therefore probability Azman doesn't qualify will be 1 minus 1/4, that is 3/4. So with this information, now we can continue. So probability R and A prime will be probability R, that is 3/5, times probability A prime 3/4. Continue with or change it as plus the second possible outcome, probability of R prime and A. So probability R prime, we have 2/5 times probability A 1/4. Okay, with that you can obtain the answer for the probability that only one of them qualifies for the scholarship. Question 7. A box contains 5 balls numbered 7, 8, 9, 10 and 11. Okay, so this will be the sample space. Now let's continue. A student draws one ball at random from the box. If the number on the ball is even, the ball is put back into the box and one more ball is drawn from the box. Okay, so remember, if the number on the ball is even, then the ball is put back into the box. So that is the first condition given. Okay, now for the second condition, if the number on the first ball is odd, the ball is not put back into the box and second ball is drawn at random from the box. Okay, find the probability that the student gets 2 balls with even number. Okay, let's define the events first. So let A as event of getting even number. So if you refer to the sample space, even number for this question we have 8 and 10. Next, let B as event of getting odd number. So odd number will be 7, 9 and 11. Okay, now let's continue with the question to find the probability that the student gets 2 balls with even number. So here we have only one outcome, that is first draw with even number and second ball also with even number. So we have only one possible outcome, that will be probability A and A. Or you may write it as probability A times probability A. So what is A? Just now we defined A as event of getting even number. So for the first time, in order to get even number, the probability will be 2 out of 5. That means we have 2 even number in the box. That will be 8 and 10. And altogether we have 5 balls. Therefore, probability A equals to 2 over 5. Now remember, if the number on the ball is even, the ball is put back into the box. That means for the second draw, okay, we have 5 balls in the box. And out of 5, we have 2 even number. So again, times with probability A, therefore we have 2 out of 5. Okay, remember, even number, the ball is already put back into the box. Therefore, left, we still have 2 even number ball out of 5 balls. Okay, simplify this to get the answer. Next, find the probability that the student gets a ball with an odd number on the first draw and even number on the second draw. So again, we have only one outcome. Remember, here the question, it is more specific. It is mentioned that for the first draw it have to be odd number, and for the second draw it have to be even number. So here we have only one possible outcome. So that is getting odd number, even B, and for the second draw we must get even number, that is even A. So probability B and A, which is equals to, okay, probability of getting odd number for the first time will be 3 out of 5. Now remember, if the first ball is odd, the ball is not put back into the box. That means for the second draw, left only 4 balls, and out of 4 balls, 2 will be even number. Therefore, probability getting even number on the second draw will be 2 over 4. Okay, simplify this to get the final answer. Question 8. A class consists of 12 boys and 18 girls. 2 students are picked at random from this class. Find the probability that both of them are girls. Okay, let's define the events. So let G as event that a girl is picked. Okay, so here you can calculate the probability of girl. So that will be 18 over 30. Why 18? Because we have 18 girls in the class. And total number of students in this class will be 12 plus 18. So total is 30 students. So that's why the probability girl here equals to 18 over 30. Next, let B as event that a boy is picked. So probability boy equals to 12 over 30. So number of boys, we have 12. So 12 over total number of students in the class, 30. Okay, so for the first question, you are asked to calculate the probability that both of them are girls. So here we have only one possible outcome. That is probability girl and girl. Okay, so you can rewrite it as probability girl times probability girl. Remember, probability girl and girl. So the word and can be replaced by times. So probability girl times probability girl. Okay, so for the first time to choose a girl, so that will be, the probability will be 18 over 30 times, okay, for the second time. Now remember, once we have already choose one girl, that means now left only 17 girls. Originally 18, since one girl is already been chosen, so left another 17, and total number of students also reduce 1, therefore left 29. So that is why for the second time choosing a girl, the probability will be 17 over 29. Okay, so you can simplify this to get the answer. Okay, the second question, find the probability that at least one of them is a boy. Now, I have already mentioned the word at least in previous video. Okay, so when it comes to the word at least, the easy way of solving this question, you just take 1 minus the probability of the complementary event. So at least one boy equals to 1 minus probability not boy, or in other words, probability girl and girl. Okay, so here since we have the probability value of girl and girl, so you just use the answer in A to substitute and get the final answer as 94 over 145. Question 9. Azlina has 6 different posters, A, B, C, D, E and F. She intends to put up 4 of the posters in a row on the wall. Find the probability that the arrangement is B, E, A and D. Now this question is different from what we have learned so far. Here it involves probability and permutation, or in other words, arrangement. Okay, so to start with, let's list out what is sample space. So sample space here will be arrangement of 4 posters from 6 posters, and the number of sample space equals to 6p4. Okay, now here you have 6 posters, but then Azlina is going to choose only 4 to arrange. So 6 arrange 4 or 6 permitted 4. Okay, which is equals to 360 arrangement. So that is the number of sample space. Next, find the probability that the arrangement is B, E, A and D. So let's define A as event of getting the arrangement of B, E, A and D. Here it is a fixed arrangement. Therefore, the number of event A equals to 1. Now you can calculate the probability of event A using the basic formula of probability, which is equals to number of event A over number of sample space. So the answer will be 1 over 360. Okay, now for the second question, find the probability that the arrangement consists of A, C, D and F. Here the arrangement must consist of A, C, D and F. Okay, that means first, okay, let's define the event. So let B as event of getting the arrangement consists of A, C, D and F. The arrangement must have these 4 letters. So total arrangement or total number of event B will be 4p4, or you may use 4 factorial. Okay, so we have 4 posters, A, C, D and F. The total the arrangement of these 4 posters will be 4p4, which is equals to 24. You may use your calculator to get the answer. Okay, now you can calculate the probability using the basic formula of probability. So probability event B equals to number of event B over number of sample space. So that will be 24 over 360. Simplify this. Your final answer will be 1 over 15. So here remember, this question involves probability and permutation. Question 10. The probability that Ashraf will pass the physics, chemistry and biology tests are 0.6, 0.4 and 0.7 respectively. Okay, let's define the events. So let P as event of passing physics, C as event of passing chemistry and B as event of passing biology. Here we are given the probability of passing the subjects. So let's start with physics. Passing physics given as 0.6. So probability not passing will be 1 minus 0.6, which is equals to 0.4. So you do the same subject for chemistry. So probability chemistry given as 0.4. So not passing chemistry will be 1 minus 0.4 equals to 0.6. And continue with biology, do the same thing. So once you have all the values, okay, now let's continue with the question. Find the probability that Ashraf will pass in chemistry only. So here we want the probability that Ashraf pass in chemistry only. That means it can be written as probability chemistry pass, physics fail. So I'm using P prime to indicate failing physics and B prime for failing biology. So you can break this as probability C times probability P prime times probability V prime. Okay, referring to the table, you can substitute all the values and find the answer. For the second question, you are asked to find the probability that Ashraf will pass 2 of the 3 tests. Okay, so here if you have doubt, you can find the number of possible outcomes using combination. Since we have 3 tests, Ali is sitting for 3 tests and here we want to choose 2 to pass. So 3 choose 2 or 3C2, which is equals to 3. That means we have 3 possible outcomes here. So let's list out all 3. So the first one can be probability chemistry fail, physics pass, biology pass, or probability chemistry pass, physics fail and biology pass, or probability chemistry pass, physics pass and biology fail. Okay, so for each possible answer here, you calculate the probability. Okay, substitute all the values and get the final answer. Okay, let's move on to question 3. Find the probability that Ashraf will fail in all tests. So fail all tests, that means here probability chemistry fail, physics fail and biology fail. Okay, so we have only one possible outcome. So get the probability. So probability C prime will be 0.6 times probability P prime 0.4 times probability B prime 0.3. Okay, multiply all this and the final answer equals to 0.072. Question 11. A committee consists of 7 members is to be formed from 6 lecturers, 3 principals and 2 teachers. Find the probability that the committee formed consists of 3 lecturers. Okay, let's start finding the sample space. So here the sample space must consist of 7 committee members. So that will be combination of 7 members chosen from 11 members. Now here we don't have to list out the possible outcomes, but we need to calculate the number of sample space. So in order to calculate the number of sample space, I'm going to use the concept of combination. So number of sample space equals to 11C7. Why 11? Because total we have 6 lecturers plus 3 principals plus another 2 teachers. So altogether we have 11 members. So from this group of 11 members, we are going to choose 7 members. So 11 C7. Okay, now you can use your calculator to get the value. Okay, next let's define the event A. So event A is event of getting 3 lecturers and another 4 members. Remember, the committee that is going to be formed consists of 7 members. Okay, so if the condition given for the first question must have 3 lecturers, meaning that we have to choose another 4 from the group of principal and teachers. Therefore, number of event A equals to 6C3. Okay, why 6? Because we have 6 lecturers. Choose 3 lecturers. N. When it comes to the word N, change the word N as times. Okay, times 5C4. 5 because 3 principal and 2 teachers. The sum is 5. So 5 choose 4. Okay, calculate this using your calculator and you'll get the answer as 100. Now, you have the value of number of event A and number of sample space. You may use the basic formula of probability to substitute the values and find the answer. Okay, let's move on to the second question. For the second question, you are asked to find the probability that the committee formed consists of 3 or 4 lecturers. So here we have 2 possible outcomes. That can be 3 lecturers and 4 others. So that will be 1 outcome, or 4 lecturers and 3 others. Okay, now if you look at question A just now, we have already found the answer for 3 lecturers and 4 others. Therefore, we can skip to the second outcome. We find the probability of the second outcome. Okay, so for the second outcome, we have 4 lecturers and 3 others. Okay, first define the event. So let B as event of getting 4 lecturers and the other 3 members. Okay, so number of event B equals to 6C4 because 6 lecturer, choose 4 lecturers and replace the word N as times 5C3. Okay, so calculate this, you'll get total as 150. So you can calculate the probability of event B now. Okay, you'll get the answer as 15/33. Now go back to the question. The question is find the probability that the committee form consists of 3 or 4 lecturers. So probability 3 or 4 lecturers, it can be written as probability A plus probability B minus probability A intersect B. Now probability A intersect B here equals to 0. So you can neglect that part. Therefore we just have probability A plus probability B. Substitute the value which we have and simplify to get the final answer. Okay, let's move on to question 12. A box contains 10 different books. One book is written in Japanese, 2 books are written in French, and the others are written in other languages. 5 books are chosen at random from the box. Find the probability of getting 1 Japanese book, 1 French, and 3 books of other languages. Now, if you look at the question here, this question also involves probability plus combinations. Therefore, let's find the sample space using the concept of combination. So, here the sample space can be defined as combinations of 5 books chosen from 10 books. Remember, here we do not have to arrange the books. You have to be careful on that. Okay, we are just going to select the books. We are not going to arrange the books. Okay, so number of sample space equals to 10. Altogether we have 10 different books. So 10, choose 5 to select. Okay, so you simplify and you'll get the answer as 252. Next, let A as event of getting 1 Japanese book, 1 French book and 3 books of other languages. So we calculate the number of event A. So that will be 1C1. Okay, here in order to select the Japanese book given only 1 book. So 1, choose 1. Okay, times 2C1. Okay, French book, we have 2 books. So 2, choose 1 book. Okay, continue times another 7 book in other languages. Okay, so 7, choose 3. So simplify, the total will be 70. Okay, now you can calculate the probability using probability event A equals to number of event A over number of sample space. Substitute the value which we have already got, then you'll get the answer. Question 13. A bag contains 3 red balls and 2 blue balls. 3 balls are picked at random from the bag. Find the probability that 2 red balls and 1 blue or 1 red ball and 2 blue balls are picked. Okay, so here let's define the sample space. So sample space consists of combinations of 3 balls picked from 5 balls. Okay, you don't have to list out the outcomes, just calculate the number of sample space. And we can do this by using the combination formula 5C3. Why 5? Because we have total number of balls in the bag as 5. So 5, choose 3 equals to 10. Next, let A as event that 2 red balls and 1 blue ball are picked. Now you have to calculate the number of event A. So in order to get 2 red balls, remember we have 3 red balls altogether in the bag. So 3, choose 2. Okay, followed by and 1 blue. Okay, and replace the word and as times. In order to get 1 blue ball, in the bag we have 2 blue balls. Therefore, it will be 2, choose 1. 2C1. Okay, simplify this and you will get the answer as 6. Now you can calculate the probability of event A, that will be 6 over 10. Next, let B as event that 1 red ball and 2 blue balls are picked. So again calculate using the combination concept. So number of event B equals to 3C1. 3 red balls, choose 1. And therefore you times 2C2. Okay, we have 2 blue balls, choose 2. Okay, equals to 3. Calculate the probability of event B. So event B equals to 3 over 10. Next, using the formula, probability A union B equals to probability A plus probability B minus probability A intersect B. Now here, event A and B cannot happen together. Therefore, the probability A intersect B equals to 0. Left, probability A plus probability B. Substitute the values and simplify to get the final answer. Okay, now we can solve question 13 by using tree diagram. For the first pick, you have red and blue, followed by the second peak, you expand it until third peak. Next, you list out all the possible outcomes. So here we have altogether 8 possible outcomes. So that will be the sample space. Next, now here we have 6 outcomes that fulfill the given criteria, which is written in red here. Okay, you can calculate the probability of the outcomes one by one and get the total. Or another way of solving this, which I find it easier, okay, you must remember the total probability equals to 1. So what do? Take 1 minus the probability of the irrelevant outcomes. That will be probability of getting red, red and red, and the other one is probability of blue, blue and blue. Now here, remember in the back we have only 2 blue balls. Therefore, getting probability blue, blue and blue is impossible, or it is equals to 0. So you can just neglect it. Next, so you can write the formula as 1 minus probability R, R and R. Okay, so in order to calculate the probability of first R, it will be 3 over 5. Why? Because we have 3 red ball, total 5. So 3 over 5 times, for the second time, in order to get the red ball, it will be 2 over 4. Reduce the value, reduce 1. So 3 minus 1. So left only 2 red balls. So 2 over 4. For the third peak, left 1 red ball. So the probability will be 1 over 3. So you simplify this and you will get the final answer 9 over 10, which is same as what we get by using the combination concept. Okay, with that we have come to the end of the lesson. Okay, so thanks for watching and please do subscribe for more videos.